Kumusta mga kasipsanayan? Welcome back to my channel. And for today's video, we are going to talk about the application of geometry in the real life. Hi! Before we start, let me first introduce myself to you. My name is Hazel Robricado, a freshman at Liban Community College, Liban Albay, and taking up a course of Bachelor of Secondary Education, major in Mathematics. The objectives of this discussion are as follows. First, the students will be able to differentiate plane and solid geometry. Second, students will be able to define parallel lines, polygons, triangles and congruent triangles, and quadrilaterals. And lastly, students will be able to appreciate and determine the real-life application of geometry. The discussion will revolve in the following topics: plane geometry, solid geometry, parallel lines, polygons, triangles and congruent triangles, and quadrilaterals. Geometry is widely used in science and engineering. The ancient Egyptians and Greeks used geometry to calculate the diameter and the distance of the moon, and scientists have been busy with it ever since. We don't have to memorize all the formulas, but it's good to be comfortable with this sort of stuff. So roll up your sleeves, have some neck stretches, and make sure that your brain is working. Let's talk first about plane geometry. The plane geometry involves the behavior of points, lines, and various figures confined to a flat two-dimensional surface. Meanwhile, the solid geometry also involves points, lines, and planes. However, the difference between two-dimensional or 2D geometry and three-dimensional or 3D geometry is the fact that there's an extra dimension. This makes things more interesting and more complicated as well. But don't you worry mga kasipsanayan, because today we are just going to focus on the plane geometry, which is more easier than the solid one. Let us now talk about parallel lines. Two lines are parallel if first, they are coplanar, meaning these two lines are in the same plane, and second, they do not intersect. We have 5 conditions which guarantee parallelism. First, two parallel lines lie in exactly one plane, or in simple words, they are coplanar. For example, if line 1 and line 2 are parallel, they both lie in plane Y. Suppose that the plane is called plane X, and we will place a line, a yellow-green line called line AB. And then, we will put a line parallel to the line AB. We will call it line CD. The second condition is this. In a plane, two lines are parallel if they are both perpendicular to the same line. For example, if line 1 is perpendicular with line X at P and line 2 is perpendicular with line X at Q, then line 1 and line 2 must not intersect. Let's have this one for the second condition. Line AB is parallel to line CD. And let's pick a color orange for another line. Let's call the line GH. And we can see that it is perpendicular. The third condition is this, the existence of parallels. Let L be a line and let P be a point not on L. then there is at least one line through P that is parallel to L. So for the third condition, let us draw another line, a horizontal one. Okay, that is line AB, and then let's make it a color blue. Color blue, okay. And then let's pick another line, a perpendicular to line AB. That's the yellow-green one, naming line CD. And then let's put another line parallel to line AB at point C. That's the orange one. This is the fourth condition. If two lines are cut by a transversal and one pair of alternate interior angles are congruent, then the other pair of alternate angles are congruent. For the fourth condition, we have line AB parallel to line CD and a transversal line EF. We're going to draw the interior angles. And here, we will see and validate that angle AEF is congruent to angle EFD, while the angle BEF is congruent to angle EFC. And that is correct. The fifth condition is the AIP theorem. Given two lines are cut by a transversal. If a pair of alternate interior angles are congruent, then the lines are parallel. The last condition is like the fourth one. That's a parallel line AB and CD and a transversal EF. But by this time, let us see if the alternate interior angles are congruent. So let's pick a color yellow. Okay. That is congruent. And the other one, the other interior angles, they are too congruent. That's correct. Given the 5 conditions, let us now see the application of parallel lines in the real life. Let us now proceed to our next topic, which is polygons. So what is polygon? A polygon is a closed flat shape with straight edges. Closed means there is no gap in the shape, and each polygon is given a name depending on the number of sides it has. A 3-sided polygon is called a triangle. A 4-sided polygon is called a quadrilateral. A 5-sided polygon is called a pentagon. A 6-sided polygon is called a hexagon. A 7-sided polygon is called a heptagon. An 8-sided polygon is called an octagon. A 9-sided polygon is called a nonagon. A 10-sided polygon is called a decagon. And when a polygon has a larger number of sides, we can just call it an n-gon, where n represents the number. For example, if the polygon has 23 sides, then we can just call it a 23-gon. Now let us see the application of polygons in the real life. Let us now proceed to our next topic, which is triangles. A triangle is a polygon with 3 edges and 3 vertices. It is one of the basic shapes in geometry. There are 3 special names given to triangles that tell how many sides or angles are equal. There can be 3, 2, or no equal sides or angles. The first special triangle is the equilateral triangle, from the root words equal and lateral, which means sides. So equilateral triangles have equal sides and 3 equal angles that are always 60 degrees. Next, isosceles triangle. Isosceles means equal legs. And we have 2 legs, right? So isosceles has also 2 equal sides joined by an odd side. It has 2 equal angles. The last one is the scalene triangle. Scalene means uneven or odd, so there's no equal side. In scalene triangle, there is no equal sides and no equal angles. Let's now talk about congruent triangles. So congruent triangles are triangles that have the same size and shape. This means that the corresponding sides are equal and the corresponding angles are equal. We can tell whether 2 triangles are congruent without testing all sides and all the angles. And in this lesson, we will consider the 4 rules to prove triangle congruence. They are called the SSS rule, SAS rule, ASA rule, and AAS rule, where A stands for angles and S stands for sides. The first rule is the SSS rule. It states that if 3 sides of one triangle are equal to 3 sides of another triangle, then the triangles are congruent. Next is the SAS rule. It states that if 2 sides and the included angle of one triangle are equal to 2 sides and included angle of another triangle, then the triangles are congruent. Then we have the ASA rule. It states that if 2 angles and the included side of one triangle are equal to 2 angles and included side of another triangle, then the triangles are congruent. The last rule is the AAS rule. It states that if 2 angles and a non-included side of one triangle are equal to 2 angles and a non-included side of another triangle, then the triangles are congruent. And now, let us see the application of triangles and congruent triangles in the real life. To further discuss triangles, I will make use the geometry pad application and we will draw some triangles. So here in the geometry pad, we can just tap the pencil icon rather, and then find the triangle section here, and we can see the different kinds of triangles. So let's draw a right triangle, and we just need to follow the instruction to tap 3 points. We can choose or change the color. And this is the right triangle ABCD, where the angle B is equal to 90 degrees. And for that, we can choose first the equilateral triangle. Equilateral means all sides and all angles are equal. So let's change the color first to violet. And let's draw the equilateral triangle at the upper part. So as we can see, there is a line to determine the the congruence of each side. So angle DEF is equal to angle EFD and angle FDE. And so the sides DE, FE, and FD. And for the last one, maybe we can choose the isosceles. Isosceles triangles means two legs and two angles are equal. So let us see and validate the accuracy of geometry pad application. Let's change the color. I want it to be red. Tap 3 points again, here, here, and here. So we have the isosceles triangle GHI, where sides GH and sides GI are equals or congruent, and the angle GHI and angle GIH are also congruent. So this is the convenience in making geometry pad in drawing triangles. And now let's proceed to quadrilaterals. A quadrilateral is a four-sided polygon having four edges and four corners. The word is derived from the Latin words quadri, a variant of four, and latus, meaning side. To further discuss the quadrilaterals, I will make use the geometry pad application. So to automatically draw a quadrilateral of any kinds, we can just tap the pencil icon, which is found here at the right side, and find the quadrilateral section, this one, and here we can see many kinds of quadrilateral. For example, let us pick the square and change the color. It is your own preference, of course. For me, I want to use blue. I want to draw it here, tap 2 points, just like it is said in the instruction. So yeah, we have now the square ABCD, and AB is parallel to DC, and as well as AD and BC. We can see also that their interior angles are all equal to 90 degrees. For the next one, we can use a rectangle. We just need to follow the instructions. Tap 3 points, it could be here. Oh, it is tiny. So let's make a new one. Sorry, rectangle. And let's change the color. I prefer red. Here and here. It is automatically drawn again. The line AB and DC are parallels, and line AB and line BC are parallels, and the interior angles are all 90 degrees. But we can see that the line AB and line BC are longer than the lines AB and line DC. For the next quadrilateral, I want to use a rhombus. Tap 3 points. The rhombus is seemingly similar with square. However, as we can see, the interior angles are not right angle or not equal to 90 degrees. The angles E and G are congruent, but they are obtuse, and the angle H and F are also congruent, but they are acute angles. Next one, we can use a parallelogram. top 3 points again, and we can change the color in any preference. For me, it would be yellow. So top 3 points, and here the parallelogram. The line AD is parallel to line BC, and the line AB is parallel to line DC. However, just like the rhombus, the interior angles are not right angles or equal to 90 degrees. The line A is congruent to line C. They are both obtuse angles, and the line B is congruent to angle D, and they are both acute angles. And there are a lot of kinds of quadrilaterals. Let's try the polygon. Top endpoints to create vertices. 1, 2, 3, 4, 5. This is my polygons. Let's create a new one. I love the polygons because we can choose how many sides we want to have. 7, 8. That's A, B, C, D, E, F, G. That would be an octagon. Let us see. 1, 2, 3, 4, 5, 6, 7. Sorry. So this is a heptagon, not an octagon. Let us proceed to the application of quadrilaterals in real life. We are now done in our topics, but before we end this discussion, let's have first a short reflection. Geometry indeed is essential in our daily lives. Even without ever cracking open a geometric book, geometry is used daily by almost everyone. It could be me and you. Your brain makes geometric special calculations as you step your foot out of bed in the morning or park a car in a parallel way. In geometry, you are exploring spatial sense and geometric reasoning. You can find geometry in art, architecture, engineering, robotics, astronomy, sculptures, space, nature, sports, machines, cars, and so much more. Geometry indeed is everywhere. Again, this is Hazel Aro Brigado, your Kasip Sanayan, and I thank everyone who watched this video. I hope that you find the discussion useful. So for the next slides, I will show you some of the geometric codes.